Quadratic Equations, Factoring, Level 6. In this video, we are going to work on slightly more challenging examples. For the most part, when you deal with quadratic equations of the form x squared plus bx plus c equals 0, you have to write the quadratic trinomial in standard form and set 0 on one side of the equation. At times, you might need to do some algebraic manipulation, combining like terms and distributing terms to accomplish this first step. Let's illustrate this with a couple of examples. Solve the equation x squared minus 4x equals 32. Alright, the first step is to get the quadratic trinomial in standard form and set one side equal to 0. So we first need to subtract 32 from both sides in order to accomplish this first step. Doing that, we obtain x squared minus 4x minus 32 equals 0. Next, we notice that the coefficient of the quadratic term is equal to 1. The coefficient of the linear term is negative, and that of the constant term is also negative. In order to check if this quadratic equation is factorable over the integers, we need to find a positive factor of 32 and a negative factor that add up to negative 4. So we go ahead and find the factors of 32. They are 1 and negative 32, negative 1 and 32, 2 and negative 16, negative 2 and 16, 4 and negative 8, and finally negative 4 and 8. Next, we find the sum of each pair. The first pair add up to negative 31. The next one add up to 31. The one after that add up to negative 14, followed by 14. The next pair add up to negative 4, and the final pair add up to 4. The factors that satisfy both conditions are located in the fifth row. So we use these values to factor the quadratic equation and obtain the quantity x plus 4 times the quantity x minus 8. Next, we apply the zero product property to each factor. So we set each factor equal to 0 and solve for x. Doing that, we obtain x equals negative 4 as one solution and x equals 8 as a second solution. Keep in mind that the first step is to always write the quadratic equation in standard form. And make sure you set one side of the equation equal to 0 before you attempt to factor the expression. Also keep in mind that this first step is not always completed for you. The problem might require some initial manipulation before factoring. With this in mind, let's go ahead and try the next problem. Solve the equation x times the quantity x minus 12 equals negative 27. At first it seems that this equation is in factored form, but there is one problem. It's not set equal to 0. It's actually set equal to negative 27. Many students blindly approach this problem without understanding how the zero product property works, and will tend to mindlessly set both x and the quantity x minus 12 equal to 0. Or they might set x equal to negative 27 and the quantity x minus 12 equal to negative 27 as well, and solve for x from there. This is completely wrong. The zero product property only works if the factors are set equal to 0. This is actually a common mistake that many students keep making, so make sure you're not one of them. With that said, we first need to rewrite the equation in standard form. Then set one side of the equation equal to 0. So we first need to expand the expression in the left side of the equation. Doing that, we obtain x squared minus 12x. Next, we add 27 to both sides of the equation, so we can set one side equal to 0. Doing that, we obtain x squared minus 12x plus 27 equals 0. Now we can go ahead and proceed with the factoring step. Notice that this is a quadratic trinomial whose quadratic term has a coefficient of 1, a negative linear term, and a positive constant term. If this quadratic equation is indeed factorable over the integers, then the potential values for r and s are both negative. So we go ahead and list the negative factors of 27. They are negative 1 and negative 27, and negative 3 and negative 9. Next, we find the sum of each pair. The first pair add up to negative 28, and the second pair add up to negative 12. Scanning the list, we see that the second row contains the values of r and s that we need to factor the quadratic trinomial, specifically negative 3 and negative 9. So we use these values to factor the expression and obtain the quantity x minus 3 times the quantity x minus 9 equals 0. Now we can apply the zero product property and set each factor equal to 0 and solve for x. Doing that, we obtain x equals 3 as one solution and x equals 9 as a second solution. I advise that you check your solution by substituting them back into the original equation, just to make sure you obtain the correct answer. Alright, let's try the next problem. Solve the equation x squared equals 3 times the quantity x minus 1. Notice that this equation seems to be in factored form. It's actually far from it. We first need to expand the factor by distributing 3 as follows. Then we need to write this quadratic equation in standard form and set 0 as one side of the equation. We do this by first subtracting both sides of the equation by negative 3x as follows. Then we add positive 3 to both sides of the equation. Doing that, we obtain a quadratic equation in standard form, specifically x squared minus 3x plus 3 equals 0. Next, we try to solve the equation by factoring. We first notice that the coefficient in the quadratic term is equal to 1. The coefficient in the linear term is negative, and that of the constant term is positive. So the potential factors of C, in other words, our R and S, have to be both negative. So we list all the negative factors of 3. It turns out there is only one pair, negative 1 and negative 3. Next, we find their sum and obtain negative 4. But this is not what we were looking for. We need a pair of factors whose sum is equal to negative 3, not negative 4. Since we exhausted all the possible integer factors of positive 3, we conclude that this quadratic equation is not factorable over the integers. Also, this quadratic equation is prime, since GCF of all the terms is 1. This means that factoring is not the way to solve this equation. We need to use another technique. We will go over how to solve prime polynomials in a later video. For now, this equation is not solvable by factoring. Let's go ahead and try the next equation. Solve the equation the quantity y plus 5 times the quantity y minus 7 equals negative 20. Once again, it seems that this quadratic equation is in factored form. For the untrained eye, that might be the case. But we first need to write this equation in standard form. Usually the way to do this is by collecting like terms. Notice that we have the constant negative 20 on one side. The only way we can add or subtract this constant with the constants within the factored expressions is to first expand the expression in the left side of the equation. So we actually have to FOIL this expression first. So let's do just that. The first term yields y squared. The outer terms yield negative 7y. The inner terms gives us positive 5y. And the last terms gives us negative 35. Next we collect like terms, so we add negative 7y and positive 5y, which simplify to negative 2y. Now we can go ahead and add positive 20 to both sides of the equation. Doing that, we obtain y squared minus 2y minus 15 equals 0. So let's proceed with the factoring step. For this equation, the coefficient on the linear term is negative, and that of the constant term is also negative. This means that one factor will be positive and the other negative. So let's keep this in mind when we start searching for the factors of 15. With that said, our first pair is 1 and negative 15. Then we switch the signs and obtain negative 1 and 15. The next pair is 3 and negative 5. And lastly, negative 3 and 5. Next, we find the sum of each pair. Doing that, we obtain negative 14, 14, negative 2, and 2 for each pair respectively. Scanning the rows, we see that the factors in the third row add up to the coefficient in the linear term. So we use these as our R and S. Having found the values, we go ahead and factor the expression and obtain the quantity y plus 3 times the quantity y minus 5 equals 0. Having successfully factored the expression, we go ahead and apply the zero product property to each factor, and then we solve for the variable y. Doing that, we obtain y equals negative 3 as one solution, and y equals 5 as a second solution. Remember, always write the expression in standard form before attempting to factor a quadratic equation. Alright, let's go over the final example. Solve the equation x times the quantity 3x plus 1 minus 2 equals 2x squared plus x times the quantity 2x plus 4. Alright, this problem seems extremely complicated. It's not really that bad. Like always, the first step is to write the equation in standard form and set 0 as one side of the equation. In order to accomplish this task, we first need to expand the terms in both the left-hand side and right-hand side of the equation. Distributing the variable x, we obtain 3x squared plus x minus 2 on one side, and distributing the variable x on the other side of the equation, we obtain 2x squared plus 2x squared plus 4x. Next, we go ahead and combine like terms, so we add the two quadratic expressions on the right side of the equation and obtain 4x squared. Next, we go ahead and start writing it in standard form, so we subtract negative 4x squared from both sides and obtain the following. Then we subtract 4x from both sides and obtain negative x squared minus 3x minus 2 equals 0. Notice that this quadratic expression contains a negative coefficient in its quadratic term. Up to this point, we have only dealt with quadratic equations that contain a positive coefficient in its quadratic term. We can fix this by multiplying both sides of the equation by -1, as follows. Doing that, we obtain x squared plus 3x plus 2 equals 0. For the most part, you want the coefficient a in the quadratic term to be positive. It makes the problem easier to work with, especially when factoring. So keep this in mind when you attempt to factor a quadratic equation. Alright, notice that both the linear and constant term are positive. So we are looking for two positive factors. It turns out that there is only one pair, 1 and 2, and their sum happens to be 3, the same as the coefficient of the linear term. So we can go ahead and factor this quadratic expression as the quantity x plus 1 times the quantity x plus 2 equals 0. Next, we apply the zero product property to each factor and solve for x, obtaining x equals -1 as one solution and x equals -2 as a second solution. Alright, in our next video we will learn how to factor quadratic trinomials where the coefficient in a, the quadratic term, is greater than 1.